Okay, now we're going to discuss the bicarb buffer system. So this system takes place within our tissues or blood and our lungs. So when our tissues go through cellular respiration, they bring out a waste product that is CO2. There are three things that the CO2 can do to get out of the blood and out of the lungs and out of the body. The first thing that it could do is dissolve into your plasma and then travel that way out of the lungs. 7% of your CO2 will do this. 20% of your CO2 will attach onto a hemoglobin on the red blood cell and ride it out of the lungs. And the third option is what 70% of your CO2 will do. And what it's going to do is it's going to go into your red blood cell, combine with H2O, and then an enzyme called carbonic anhydrase is going to turn it into carbonic acid or H2CO3, and then it's going to dissociate into H plus and HCO3 minus or bicarb. The H plus is going to attach to a hemoglobin, and the HC3O minus is going to do a chloride shift. So the HC3O minus is going to go out into the plasma, and this chlorine is going to come into your red blood cell. So once it's out, it's going to go through all of these steps in reverse to go back to H2O and CO2 within your lung, and then it will be breathed out. When someone is experiencing a sickness like COVID, they're not going to have surfactant on their lung, which means they're going to have pressure issues, which means that their lung could collapse a little, and that means that this H2O and CO2 might have trouble getting into the lung and then out. So when that happens, you're going to have a buildup of CO2 within your blood, which is called the Bohr effect. And this is going to make your blood really acidic, and that's going to cause you to be drowsy and struggle with glucose utilization.